हेलो दोस्तों, कैसे हो। मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं। डिजाइन ऑफ वेल्डेड जॉइंट subjected to eccentric loading. Now what is eccentric loading? Now for eccentric loading we'll need this concept of double parallel and single parallel, so that's why I had taken only this much. Now what is eccentric loading? Eccentric loading is like this. So this is one plate, this is one plate, and then there is another plate is like this. Okay, and these two plates are say subjected to load here. Okay, when they are subjected to load here, we will not call it as eccentric load. We will not call it as eccentric load because this is not eccentric loading. So when it will be eccentric loading, this will not be called as eccentric load. Eccentric load will be called, it will be called as eccentric load when the load acting is here on this plate here, or from upward or downward from wherever. And where is the loading? Where is the welding? Welding is here. Okay, this is which weld? Single parallel fillet weld. Okay, correct. This now becomes double parallel fillet weld, and this becomes now combination of single transverse and double parallel fillet weld. So the weld applied can be either at three places or at two places or at one place only. We have understood now what is double parallel, single parallel, double transverse, single transverse. But here the load applied is not along the CG. CG of what? CG of this. So this C-shape weld, this C-shape weld, we will have to find the CG of this, and if the load is applied here, suppose the CG is coming here. Where is the load applied? Load applied is here. So is it acting along the CG? No. So this is eccentric load. Had this load been acting here, had it been acting here, then it would have been called as direct load, direct load. Now, can this eccentric load be converted into direct load? Yes, it can be converted into direct load. How?
Sir, by putting two forces in the upward and opposite direction so that it
Correct,
cancels out.
correct. So instead of this black color, say P load, what I will do, I will apply two forces here of equal in magnitude, opposite in direction. Let me call them as P1 and P2, and I write here P equal to P1 equal to P2. Now this force P is what? It is direct load. Force P is direct load. Whereas P2 and force P1 is direct load. It's my mistake. P1 is direct load because it is acting along the CG, and P2 and P is trying to tilt this load weld system. It's trying to tilt it like this here, and because of this, it will create another stress, and that is shear stress. So P1 and P2 are creating secondary shear, whereas P is direct load. P is direct load. And it is creating what? It is creating primary shear. It is creating primary shear in what? In this weld, this and this. Okay. Let me take the case of shear, exclusively shear. So these are the two plates, and they are welded here. They are welded here. They are welded here. And another welding is here, which we cannot see from the top, but I am drawing it here because this welding will be from the bottom. So we cannot see at the top, but still I am drawing it here. See now this load is acting along the CG. Say if this is 100, this is 100, and this load is acting at distance of 50, then is it acting along the CG? Because vertical CG is here. Okay, no issue. Horizontal CG, so this is acting at distance 50. So this is what? Direct load. And what is this direct load trying to do? It is trying to shear this weld. It is trying to shear this weld from here. Okay. And if if there is a weld here, there is a weld here, then this direct load, this is trying to shear this as well. This is trying to shear this as well. So in any case, there will be shear stress. The weld will be subject to shear and not tension, direct shear in all the three cases, because the weld is applied in such a way that in any case it is going to be sheared off. Okay. So obviously the first step will be to find what? The first step will be to find the CG of this weld system. Okay, क्योंकि CG से तो हमको eccentricity पता चलेगा ना, eccentricity E. So first step will be to find CG. So that we'll discuss in the numerical how to find CG. Now in this theory, what I am going to explain you, I am going to explain you how to find tau 1. Tau 1 is primary shear and tau 2 that is secondary shear. Now this is the sketch already drawn. So instead of drawing it again, I thought I will pick this one only. Now you can see this is a weld, this is another weld. These are parallel weld, double parallel fillet weld. This is the size of the weld, length of the weld L, force applied is P, E is the eccentric distance considering this point is G, and we have here primary shear. So I will write here primary shear, primary shear, that is tau 1. What is it? Primary shear is what? Load upon area. Okay, what is primary shear? Load upon area. What is load?
Sir, the stress acting P.
Okay, so load upon area, load is P. Load is P. Minimum area of weld, that is T into L. T into L. Now this, since this is double, so I will write 2 into T into L. Now T can be written as 0.707 into S. So I can write tau 1 equal to P upon 2 into point 707 into L into S. Okay, this T is replaced. So this comes as tau 1 equal to P upon 1.414 L S. Okay, this was already explained in earlier concept, and this is just applied here. So tau 1 is equal to P into 1.414 LS. Had it been only single parallel, then it would have been only 0.707 LS. Okay, if it is combination of single transverse and double parallel, then area will change accordingly. Okay, so that we'll see afterwards. Okay, now you remember that in case of bolted joint, there was an assumption that force is proportional to length. Here also we are taking the assumption that the stress is proportional to distance. Stress is proportional to distance. So if the stress is tau somewhere, then the distance is r, and this distance is from CG, from CG. So you can see in the sketch, r is the distance from the CG, and at that point r, the stress is tau. And we are talking about this small area dA. So out of this, out of this weld, ये पूरा weld है ना यहाँ पर. So I am drawing it here, this weld. Now there are infinite areas. I am considering this much area here. This area is dA. Okay, can you see in the sketch? Here, this
Yes, sir.
area is dA. This area is dA, and it is at what distance? It is at distance r from the CG, and the stress acting at this area is tau. Okay. Now what are we going to do? We are going to find tau 2. Once we know the value of tau 1 and tau 2, we can add it. Now tell me, if tau 1 is vertical, and tau 2 is vertical. So what will be tau? What will be tau?
Sir, tau 1 plus tau 2.
Correct, tau 1 plus tau 2. But if tau 1 is vertical, as in this case, but tau 2 is not vertical, how tau 2 will be vertical? You can see here, tau 2 or shear stress 2 will be perpendicular to the distance. Okay, stress is perpendicular to the distance. So tau will be like this, perpendicular, tau 2. perpendicular to the resistance here. So can we add tau 1 and tau 2 in that case? No.
Root over tau 1 square plus tau 2 square plus
Yes,
tau 1.
we will have to use graphical method, or we will have to use law of parallelogram of forces, correct? Okay, so now we have understood that tau 2 is not vertical, whereas tau 1 is vertical. Tau 1 is primary shear stress is vertical, but tau 2 is not vertical. It is inclined at some angle to tau 1, that is theta. So what is theta? Angle between tau 1 and tau 2. Theta is angle between tau 1 and tau 2. Okay, now what we have to do? We have to find first tau 2. After we find tau 2, that is secondary shear stress, we can add it and then we will get final shear stress. और ये final shear stress के साथ हम क्या find करेंगे? We will find is T, thickness, throat thickness. Okay, so coming to the calculation of tau 2. So here I have shown you that T is, I am saying that assumption tau is proportional to R. So what I can write here? I can write here tau is proportional to R. So I can write tau 1 is proportional to R1, tau 2 is proportional to R2. Okay, now since we are talking about secondary shear stress, we will say consider this, इसको ignore करते. So I can write tau upon R equal to tau 2 upon R2. Is it clear? So from this I can write tau 2 equal to tau into R2 upon R. Okay, I am going to use this afterwards. Now, the area dA that we have considered, now the area that dA that we have considered, okay. So what will be the force on area dA? Force will be equal to this dA into tau. Force is area into stress. Okay, so I can force is area into stress. So what is the torque acting on area dA? Torque acting on area dA is dt is equal to dA into tau into what is torque? Torque is force into distance. What is force? This is force. This is force into it is acting at what distance? R distance. So what is the torque? Torque is equal to area into torque is equal to force into distance. What is force? Force is dA into tau. What is distance? Distance is R. Okay. Now, tau, instead of this tau, I will use tau 2. Okay. So, let me change this. I want tau. I don't want tau 2 because tau is not, we are not interested in tau. We are interested in tau 2. So, that this gives me tau equal to tau 2 into R upon R2. Now, this can be replaced as dA into, instead of tau I will write tau 2 R upon R2 into this R, so it becomes R square. Now this torque is acting on area dA. Now are we interested in area dA? No, इतना छोटा area पे interested नहीं है, we are interested in the entire weld. So if I talk about entire weld, there are thousands of dA area. If I want to find the torque on this entire weld, what I will do? I will integrate this. Integrate dt. So what I will get? Integrate dt. Integration of dt is equal to integration of dA tau 2 r square upon r2. Now out of this, uh, I will write it here. Next, integration dt equal to integration of dA integration of r square dA is what? Polar moment of inertia. So I can write here J r square upon r2. J r square upon r2. Is this much clear? Now integration of dt can be written as T. Where is this one? Here. T is equal to J r square upon r2. Am I correct? Am I missing tau 2 here? Tau 2 I am missing. See,
Yes, sir. Sir,
tau 2
R
I
square
have.
will be there, na? R square dA is J, na?
R square d is j, so I should have written tau 2 here, correct?
Yes, sir.
See, R square dA is what? R square dA is j and tau 2. So instead of R square, there will be equal to j is there, tau 2 is there, and R2 is there. Now T is what? T equal to torque, that is force into distance. So T can be replaced by P into E is equal to J tau 2 upon R2. From this, tau 2 is equal to P into E into R2 upon J. So this gives us the formula for tau 2. Now somewhere in some book you will find this tau 2 is equal to M R2 upon J. What is M? M is torque and that
Into.
is force into distance P into E. And they call it as Mr. J. Mr. J. Tau 2 is equal to Mr. J. Just to remember. Mr. means M into R and J. So this way also you can remember tau 2, Mr. J. So we got this tau 2, that is secondary shear stress is equal to P into E into R2 upon J. Now we have tau 1, we have tau 2. Where is tau 1? Tau 1 is acting like this. Okay, this is the weld, this is the weld. Tau 1 is acting like this. Tau 2 is acting here. This is G, this is R2, and this is tau 2. So how will we add tau 1 and tau 2? So tau is equal to under root of tau 1 square plus tau 2 square plus 2 tau 1 tau 2 cos of theta, where theta is equal to angle between tau 1 and tau 2. Okay, this way you can get the value of tau. Also you can solve it like this. The same thing I am drawing here again. This is G, this is R2 distance, this is tau 2. Tau 1 is vertical. What I will do, I will resolve it into two components. This is tau 2, this is theta because this is tau 1, similar to this, not tau 1, this is theta, this is tau 2 sine of theta, this is tau 2 cos of theta. So what will be tau here? Tau will be tau 1 plus tau 2 cos of theta. Here I have added it algebraically because both are acting in direct vertical direction, and here I cannot add because this is a total force. We have to add on the result component of this. So either you do it like this or you do it like this, you should get the same answer. I hope the things are clear to here.
Yes, sir.
Good. Now this is a catch here. Somewhere you in some book this is given. This is given. Okay, so you may think ये कैसे आ गया? Or again when you are attempting some examination, that time a question will be asked based on this. So this tau 2 and this tau 2 cos theta you can, sorry, tau 1 and tau 2 cos theta you can directly add because they are their line of action is in same direction. But you cannot add tau 2 and tau 1 because tau 2 is acting in some different direction. So you have to add the component of this. So either you do it like this or you do it like this. Finally, we have to find the value of tau, and then from this tau we know P is equal to 1.414 ls into tau. Okay, so we'll use this formula. So this we'll see in tomorrow's lecture how to find the value of the thickness, throat thickness or something, or say size of weld, whatever is asked. Okay, so just before I conclude, we are discussing here the eccentric load. Because of the eccentric load there can be two stresses. One is the primary shear stress and second is the secondary shear stress. Primary shear stress can be easily found by this formula, P upon 1.414 ls. Again, this formula will change depending on how many welds are applied. And tau 2 is very much easy to remember. It is Mr. J, MRJ, and M is what? P into E. What is R? R is R2. Okay, I will tell you about this R2. So Mr. J, that will give us the value of tau 2. Once we know tau 1 and tau 2, we can add it either this way or this way, and we will get the value of tau. And then that tau value will be used to find the value of throat thickness T or size of weld S. Now why R2? Why R2? R2 is what? You can see R2 is the distance of the centroid from the
Tau.
farthest point. Farthest point. Yes. Now why R2? Can anyone tell me this? Why R2? Why
Sir,
not this?
is the distance from centroid to tau 2.
Can you repeat,
Sir,
Amen?
sir, R2 is the perpendicular distance from centroid to tau 2. Hence, we can take R2.
Nee, R2 is the distance from centroid to
Tau 2.
tau 2. Tau 2 is not anything. Tau 2 is nothing. Okay. I can say R2 is the farthest distance, that is point A. R2 is the
Sir, because,
farthest distance, point A from G.
sir, because this load P that will act, that will try to tilt it from that point. So, sir, we
Ye-
will take the farthest distance from the material. Sir,
Correct, correct.
where it is going to tilt.
Exactly. If you remember the design of bolted joint, we had seen that कौन सा bolt पहले टूटता है जो farthest distance पे है वो bolt पहले टूटता है. Okay. Similarly यहाँ पर भी weld टूटना कहाँ से चालू होगा? It will be at the distance which is farthest from the CG, and the distance which is farthest from the CG you can see here clearly from the sketch is R2. Because if I talk about G joining this point, okay, यहाँ पे, then this distance will be obviously less than this distance. Okay, so we have to always find R2. Okay, R2 कोई दिया नहीं रहेगा एग्जाम में, कहीं क्वेश्चन में दिया नहीं रहेगा. R2 has to be found by us. Okay, and why R2? The reason I have explained. Why R2? Because R2 is the farthest distance.